Welcome to video 8. This video is going to be a little bit of a recap. We're going to try and have a look at some of the processes and problems and stuff that we've had in previous videos. What we're looking at here is the symmetrical transformer that we got to in video 6. Now video 6 didn't get a lot of views, but I think it's a fairly important video to actually watch. Video 6 gave us a footstep, if you like, in the door to understand what was actually going on in the coils. To understand further on what we needed to do to try and get the machine actually, I always try and put generate inside quotes, but to generate excess electrical power. Electrical power is not generated at all, it's actually always there, it's actually pumped. And the first person that I know of to actually say that was T. Henry Moray in the Moray device. If you go and read his papers, very interesting papers. I read them when I was a young fella, read them again probably about maybe 5 or 7 years afterwards, and then I didn't read them for a little while and read them again going back maybe 5 years ago now, and they were actually very insightful as you go over information. We may even see in this video, as you see information, you'll start to sort of think, oh okay, yeah, I get that now. So sometimes reading something doesn't always mean that you're going to first of all understand it, and then second of all grasp it on a mechanical level. Anyway, what we are looking at is the two coils, the symmetrical device that we tested in video 6. Now what we did do is we turned video 6 into an asymmetrical device, and this is what we got. So we've got a coil at the top, and then we've got a coil at the bottom, but we also wrapped a third coil on top of that. So if you wanted to say we have a primary, and then under the primary we've got a secondary, and then over here we've got a tertiary. That's the way I like to think of it, is there's always a tertiary coil. Now you can see here we've got one output, and then down here we've got another output. These are the same wire gauge and from the same coils, but one of these coils is down here under the primary, under that one that's coming out here. So by introducing asymmetry, because this is now an asymmetrical transformer in the way that we've got an output coil up here, an output coil down here, but also we have an input coil down here. So the input coil that's down here gives us a third coil, which now makes this whole setup asymmetrical depending on how you configure it. Okay, we've got lots and lots and lots of transformers out there that might have 3 windings on it, but always what happens with the 3 windings is the outputs are always the same. Okay, you always have a voltage on one terminal, current would come out obviously in the normal fashion. Whereas what we're doing with this transformer is we're actually turning the normal fashion, the normal current, we're turning it around on itself, and we're saying this coil over here is not going to oppose the primary, it's going to oppose the secondary down here. Okay, so if we have the 22 or 25 turn coil that's here, if that's our primary, and we have a secondary underneath it, and this is a tertiary, then our tertiary is going to oppose a secondary, which will at the same time assist the primary. So we need to make sure that our currents are configured in a way that they always oppose. And we've seen this before. We've seen it before, and we've seen it here. Okay, this is one This is, say, our tertiary coil here. This gold coil over here is our secondary coil, and the green coil here is our primary coil. Okay, the arrows here indicate the direction of the magnetic field. Okay, so this one's pointing in, and the magnetic field from the tertiary coil over here is also pointing in. So we have a image here that gives us a very good depiction of what needs to be done with the coils. Okay, an asymmetrical transformer, it doesn't always need 3 coils, but 3 coils is a start. But an asymmetrical transformer comes from how it's configured. Okay, and if we always have this coil over here opposed the gold coil over here, so if we have 2 secondary coils and the 2 secondary coils oppose each other, then at any one point in time, one of these coils must assist the primary. It's just how it is. So if you have three magnetic fields, which would be one from the primary, one from the secondary, and one from this tertiary coil, if we have 3 magnetic fields, then one of them has to assist the primary. It's pretty important. Now we see this here, and here's the sawtooth waveform.
There we go. Okay, you see the L1 coil here. It's 3-inch Baker-Williamson coil. It's had the 4 turns taken out of the center here, and they're made into a pigtail, which forms the the negative ground out, or the amperage end of the deal. On the ends here, they're coming off and going out and coming through. This is a series of very high voltage capacitors that are normally found in flyback transformer circuits and televisions. So we're into very high voltage on those diodes. And basically what they're doing is what the 2 diodes were doing in the other device. They're taking a sawtooth pattern and changing it into a flat pulsating DC.
Okay, so again, we've seen this before. Okay, this is the 10% on time with a 90% off time. Okay, so from this spike here to this spike over here is off time, but you'll see that's the gradical line, it's the 0 gradical line for this trace, that this current coming out all the way down to the next switch on. Okay, so the frequency would be measured from here to here. Okay, that would be 1 cycle, and that 1 cycle consists of an on time, which is the 10% here, and then an off time. Okay, the 10% here is where our 2 partnered output coils are configured to oppose each other, and because they oppose each other, for each magnetic field that ramps up in time, and we saw our ramp up before in an earlier video 6 I think it was, we saw our ramp up, but because we have no impedance, 0 impedance, it can ramp up very fast, Okay, so the output coils can have a current that is produced very quickly in a very short time, which can be very high depending on the voltage amplitude that you get these coils up to. Remembering these coils, these traces here are measuring current. This one on the current on the, I think that one's the light, and I think this one here is the other circuit, the diode coil. So these are 2 separate coils, 2 separate waveforms, but they do match up. You can see that there's an on time and this is an off time, and you can see if you look very closely, it's the gradical line there, so anything above, there is a ramp down there. You can see this is ramping down as well, ever so slightly. Remember, this is just a very simple experiment, This is a throw together, if you like, from a symmetrical transformer to an asymmetrical transformer, and we just luckily had a little bit of success with it. Okay, this is something that I have not played with, I have not tuned it, I've not done anything to it other than throw the coil on and give it a 10% duty cycle at 3 kilohertz. So this is non-tuned, non-everything. This is just, here it is, it's working, this is what you need to look for, sort of thing. Okay. Once you get this, once you achieve these results, okay, so remembering this is the on time in here, and this is the time that the two partnered output coils are arranged in such a fashion to oppose each other, and when they oppose, they will climb up to a maximum amplitude. You'll see the maximum amplitude gained, and then you switch off, and then it ramps down again. This is Tom Bearden's asymmetrical regauging, and we'll just have a quick look at that now. I was lucky enough to have a little bit of communication with Tom Bearden before he died. I liked the man. I thought the man was a very genuine human being. I really liked him. I got a great deal of respect for Tom Bearden. As far as I remember, every single email that I sent him, he replied to every single one. On his website, I think there are a couple of replies that he has posted to his website that I've sent him in the past. Just simple things. Some of them are pretty straightforward. So I just wanted to put that in. Great deal of respect for the man. In saying that, some of the things that he has said, and there is a very, very small portion, some of the things that he said I've found not to be 100% correct. I believe, and I don't know this for sure, but I believe Tom Bearden may have been misled a little bit. Anyway, in saying that, Tom Bearden talks about fields oscillating and all that sort of thing. We've proven that can't work. We've proven that it doesn't work in these devices. However, in saying that, it depends on the point of view that you're looking at. If you're looking at a couple of coils that are actually making the field oscillate and making the field do what it's going to do, then if the coils are introduced to make this happen, then yes, it's true. However, if that's not being talked about, then unfortunately that can't be true. Anyway, asymmetrical regauging. Tom Bearden talks about some pretty important things in here. Asymmetrical regauging is one of the most important things. Worth going through and having a little bit of a read. This is on the principles of permissible over unity EM power systems. Talks about very important major sort of principles. You know, this is sort of what Tom Bearden considers as important. And in here he does talk about many different things, that some of them are very important, some of them possibly not quite so important. Talks about Floyd Sweet, Gabriel Cron, various others, perhaps not really in the same basket as Cron and Sweet. But anyway, so some of these, obviously, they do produce some pretty reasonable outputs, which is not hard. You can do this. You can achieve this on the bench with very minimal experience. If you follow everything that we've given you on the website, if you follow everything, all the answers are there. Okay, all you need to do is copy the experiments that I've been doing, or copy the experiments of some of the others on our website, and it can be done. Okay, you can do this. You can build your own power system that is above unity. Okay, it's achievable. So don't think that you can't do it, because it is achievable. Anyway, this is quite a long document, so I don't want to spend too much time on here, but go through it. Tom Bearden does talk about asymmetrical regauging. it's a very critical aspect of these machines. Without asymmetrical regauging, uh, above unity systems are highly improbable, if you can understand where I'm sort of coming from. Some systems may be symmetrical, but if they're symmetrical, getting above unity output is unlikely. Possible, but unlikely. Alright, so what we're going to do now is we're going to have a quick look at the horizon here. Okay, so if this here is the on time, okay, so this here is where the switch in is done, then we can see that the coils, sort of like a curve if you like, but the coils are ramping up pretty quickly up to here, and then all of a sudden they switch off, and we see a bit of a spike when they switch off, and there's a good reason for that. Obviously the time rate of change of the magnetic fields. Okay, so if we've got current in both coils, or all three coils, the current moving up, when it's switched off, there's going to be a big slap together. Okay, so the coils are going to go bang. The coils already are opposing, but there's going to be a little bit of a hiccup here, and that's when they decide to go down. So that's the sawtooth waveform. So this part in here is important. Okay, bringing a symmetrical machine into asymmetrical, or introducing asymmetry, is where the coils, the part and output coils, oppose. So we must have currents that oppose in each coil. And we've got to remember that this effect, this opposing in this coil and opposing of the secondary coil, if you like, under here, it's a resonant type of effect. So there's a time, if you like, that this coil will take to change when this coil changes, and when this coil changes, there'll be a time that it takes for this coil to change, and there'll be a resonant, if you like, a bell ringing sort of type effect between these two coils. That's a little bit like the LC circuit that we looked at just before. Okay, so it's a resonant effect. They're trying to push back on each other. The harder that this pushes back on this coil down here, the harder that this coil down here pushes back on this coil. But because we've found a resonant effect, that effect will happen very quickly between the two coils at minimum impedance. There'll be 0 to even negative, possibly negative impedance. So this is going to happen very, very fast, and that's why we had to zoom right in here to see the increase up here. Look guys, I just want to say I'm doing the best I can to try and explain what's going on here, and I do worry sometimes that sometimes I'm not getting this across properly. I worry that sometimes I've either confused people, or people perhaps don't really quite understand what's going on. Like I've sort of said in the past though, you don't really need to know everything, so don't worry if it's sort of, you know, like it sort of feels like it's, wow, I've got so much information to learn. Don't worry about that. Just sort of try and get that mental picture in your head of what's going on between the two coils. Once you sort of get that mental picture in your head, then obviously this will become easier, and you'll pick up the other things as we sort of go along. The important thing is get yourself something that you can do a 10% duty cycle or even less. Something that you can push a reasonable amount of current through, so you might want to maybe do up to maybe 5 amps or possibly even a little bit more, without too much trouble. Remembering it's going to be a very short duty cycle, so your input coil, the input coil is important. If we had an input coil that had, say, 10,000 turns on it, and it was, you know, maybe a 0.5 millimeter wire or something like that, so it was half a millimeter wire, and we had perhaps, like I say 1,000 turns or something, then the response time on that coil is going to be very, very slow. Okay, it's going to take a fair bit of time to get that coil up to a maximum current, which we've already talked about this in one of the previous videos. I believe it was video perhaps video 5 maybe. So we do want an input coil that is going to be able to have that jolt. Remember, we talked about in the past, we found that it's the change of current that creates a voltage. Okay, you can push as much current through the wire as you like, but the change, if it's not changing, then it won't produce any more voltage. So the change in current, so by the time we switch on, okay, so we switch our voltage on across the coil over here, and bang, the voltage is on. But if the current can't change very quickly in the coil over here, if it's very slow change, then we're going to have very little voltage that's generated. But if we have a, say, a 2-turn coil and it's number 2 wire, so it's 2mm wire, as soon as we switch on our voltage, our coil is going to have current that rushes through really, really fast. And what will happen as a result of that current changing very quickly in that coil is we'll get a very, very high voltage on the output coils. Okay. Now I've said all along, and this is a disclaimer, one of many. Don't go too high in your voltage. Okay, keep your voltages low. This is very, very, very dangerous. Okay, if you go high voltage and if you don't start off, like I've said all along, start off small, start off with low voltages, look for the effects. Okay, potentially this could be very, very dangerous. So keep your voltages low. Don't go too high a voltage. Okay, just remembering what I've sort of said is to give you an idea of what is required. But again, don't go too high voltage. Don't push 10,000 volts through 3 turns or whatever. It's gonna blow everything to smithereens, and you're gonna end up possibly killing yourself. So please don't do that. It's very dangerous. Alright, so moving on, just want to say, just protect yourself. Just start off low voltage with only a few turns, with protect your equipment, the whole lot. So be very, very careful. Okay, start off with very, very low voltage on the input, very low voltage. It's very easy to turn it up if you need to. So start off low voltage and just check your machine, just make sure your machine's okay before switching, to a slightly higher voltage. And always load your machine. Always, 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 always load your machine. You have to have a load to be able to see what's going on, because remember, it's the currents themselves that actually make this work. So the interaction of currents that are sort of switched through the coils at a particular time, that's what makes this work. So you must have a load at all times, and if a load blows, change it straight away. Stick another light in, so have plenty of lights on standby if you need it. Anyway, I think this video sort of gets the point across. That's video 8. This video is sort of a summation of all the way through 1 through to 7. Again, video 7 was a fairly successful experiment. We got what we were looking for, only in a couple of experiments. We found lots of problems through the previous experiments that we needed to overcome, and we did, through breaking it down to the smallest possible pieces and to look at exactly what was going on, finding the problems by just a mathematical process. We were just going through looking at the problem and trying to find methodical solutions. So we're sort of methodically going through, going, okay, well, this coil is choking the other coil off. What's going on? Okay, well, this is what's going on. Okay, so what we need to do is we need to do this. Just remembering this is just the start. This is just the start. Technologies to come in future years are going to be way beyond this. This is amazing. This is just the start of a whole new world. This is the start of a whole new magnetics. You've got to remember that when Nikola Tesla bought an AC power changed the world. And wow, did it change the world alright. You know, we went from almost, you could say, caveman sort of society to civilized society all in, you know, a matter of a few weeks. So this will change the world. This is already changing the world. We already have stamped our mark on the world. Again, this stuff is not, no one else knows what we know. No one else is as far ahead as what we are. This technology is being shared primarily by AboveUnity.com and HighIQ.org. Other people that are sharing information, okay, I just want to say, I respect everybody, but please be aware that some people may be out to mislead you. So just be aware, do the experiments, stay open-minded, look for the facts. And that's the point of this series. That's the whole point of this series of why I've tried to get these videos up, is look for the facts. Look at what works. Okay, look at what doesn't work and then find out why it doesn't work. This is, again, this is a start of a whole new technology. You know, we have magnetic fields, the interaction of magnetic fields that have not been thought about before. This is new. This has not been done before. So I encourage everybody, please share your experiments, share them on the website, create a new thread, do what you can do to help us further this information to other people. So share it between all your friends, and very, very soon science will be forced to catch on and forced to catch up. When science does catch up, it'll be a momentous achievement. So again, I want to thank everybody, everybody that's been part of this huge effort. If this video has helped you in any way, I would like to ask, please consider a donation. This information it takes a lot of time to get this information out to people. It takes a lot of time to organize it. It takes a lot of time to try and get good quality pictures, images, all that sort of thing. Some of it is hard sometimes, depending on light and all that sort of thing. I do apologize for those fuzzy photos and stuff like that. Stick with it, and just remember that AboveUnity.com is where it's all at. It's all happening here. HighIQ.org for research, for reference material. There's tons and tons and tons of information there. There's a few calculators that'll be handy for a lot of people. So yeah, look, come ask questions, build, do the whole lot, join in. It's going to be awesome. Thanks again.